We have all the normal suspects in today's show. Galaxies, early life, and even some good news about international cooperation in space.
And a large rocket and a ship made for an even bigger one to help Boeing's Starliner go to space on time.
And Neptune's atmosphere is surprising us. We really need to send a mission there.
In this week's What's Up, we have another meteor shower and some planetary antics.
All of this and more right here on the Daily Space. I'm your host, Dr. Pamela Gay.
And I'm your host, Eric Mattis.
And we're here to put science in your brain. There are certain fundamental questions that most of us ask at one or more points in our life. One of the questions, how did life begin, is a science-spanning question that requires chemistry, biology, geology, and planetary science to begin to approach it. And as we get better at working together to study our solar system, the possible story of life is getting more and more interesting. Trying to understand the earliest periods of our world's history is complicated by the lack of ancient land preserved in our current landscape. Only a couple of places retain relics of the most distant past. One of those regions is Quebec's Nuvégituck Supercrustal Belt, or NSB. This band of rock was once part of an ancient seafloor located near hydrothermal vents. In the modern ocean, we find life clinging to the sides of similar vents that release heat and various nutrients. This is life that requires no sunlight and thrives in its own deepwater ecosystem. The rocks in the NSB are between 3.75 and 4.28 billion years old, and researchers have gone fossil hunting in these rocks. Researchers sliced a fist-sized rock into narrow slices and scanned them with microscopes to look for signs of biological structures. While many of the possible bacterial life structures they found, things that looked like tubes, filaments, and ellipsoids, could be the result of chemical reactions, researchers also found what they describe as, quote, a stem with parallel branches on one side that is nearly a centimeter long, end quote. Researchers have not found a way to explain this stem except as life. These results are published in Science Advances in a paper led by Dominique Papineau, who explains, quote, using many different lines of evidence, our study strongly suggests a number of different types of bacteria existed on Earth between 3.75 and 4.28 billion years ago. This means life could have begun as little as 300 million years after Earth formed. In geological terms, this is quick, about one spin of the sun around the galaxy, end quote. Let's take that conclusion and look more broadly at our solar system. This result implies life can form very quickly once a world starts to solidify and cool. Evidence points to both Venus and Mars having vast oceans early in their history. There is also the tantalizing possibility that Europa has this kind of deep ocean vent today. We have no idea if life forms easily, or if it was an impossibly improbable event that somehow started life on Earth. If life does form easily, we can look forward to potentially seeing similar fossil finds on Mars and similar life living its best life on Europa. And that is awesome. While the origins of life is a fundamental question, even for 5-year-olds, for us astronomers, there are some more specific fundamental questions, like where do supermassive black holes come from? As near as we can tell, as far back as we look, there are massive galaxies that have supermassive black holes in their centers. Forming these black holes doesn't appear to be a process that involves small black holes merging into increasingly larger black holes. Instead, they had to form through some other process we don't see happening in our modern universe. One idea has been that massive clouds of material may have been able to collapse into the first galaxies. These dusty systems would have massive star formation, and through turbulent processes, they would also funnel material into their cores where supermassive black holes formed. While theorists can create this kind of galaxy in their software, the universe hasn't exactly been providing us galaxies to study. At least not until now. The Hubble Space Telescope has discovered a galaxy cataloged as GNZ7Q that seems to fit the bill. This discovery is published in Nature in a paper led by Seiji Fujimoto, who explains, quote, "Our analysis suggests that GNZ7Q is the first example of a rapidly growing black hole in the dusty core of a starburst galaxy at an epoch close to the earliest supermassive black hole known in the universe. The object's properties across the electromagnetic spectrum are in excellent agreement with predictions from theoretical simulations. GNZ7Q provides a direct connection between these two rare populations and provides a new avenue towards understanding the rapid growth of supermassive black holes in the early days of the universe. Our discovery is a precursor of the supermassive black holes we observe at later epochs." End quote. This far-off galaxy was very much a needle in a haystack. Located in a well-studied region of the sky called the Hubble Goods North Field. This system, it shines faintly from the background as it forms 1,600 stars per year. Co-author Gabriel Brammer explains, quote, "GNZ7Q is a unique discovery that was found just at the center of a famous, well-studied sky field, showing that big discoveries can often be hidden just in front of you. It's unlikely that discovering GNZ7Q within the relatively small Goods End survey area was just dumb luck. Rather, the prevalence of such sources may in fact be significantly higher than previously thought." End quote. The lesson here is, look at every smear of light, because you never know which one will be awesome.
One of the more unusual stories this week, and another I really didn't expect to happen, was the surprise delivery of the next Atlas V first stage to Cape Canaveral on NASA's Pegasus barge. The ULA factory is in Decatur, Alabama, and its rocket stages produced there are transported on different rivers in the U.S. using the dedicated chip called the RS rocket chip. The rocket chip can navigate both the shallow waters of the rivers and the open ocean to deliver rockets to Florida, or through the Panama Canal to California. This method contrasts to SpaceX, who designs their Falcon rocket stages to be road transportable. The reason that Pegasus had to be used instead of the RS rocket ship was because of a lock closed for maintenance on the Tennessee River, preventing the large rocket ship from moving. The Pegasus barge was designed for, first, the Space Shuttle external tank and now the SLS core stage, so it can handle large rockets. The Atlas V first stage is 33 meters long and 3.8 meters wide. To get the Atlas V stage to Pegasus, ULA first put it on a barge which could fit through a smaller but open lock and took the stage to where Pegasus was. From there, Pegasus took it the rest of the way, following the usual route of the rocket ship. This Atlas V core stage joins the already stacked Centaur and Interstage, plus 2 solid rocket boosters for the Starliner OFT-2 mission. The original first stage for Starliner's OFT-2 mission was used by the Lucy asteroid mission because of the tight turnaround required. The Centaur could not be used for the Lucy mission, as it was specific to the Starliner configuration, with 2 engines rather than 1. Starliner OFT-2 is expected to launch in May. Spacecraft. This is how we know so much of what we know. And now we look at some science from other missions. Stay tuned.
It's spring here in the Great Plains, and that means the temperature can swing from snow boot weather to shorts weather in 24 hours with a dash of tornado in between. The chaos we see here, however, may be the normal outrages of a planet having to change seasons. New analysis of Neptune shows, well, I'm just going to read from the press release. Quote, "The ice giant's global temperature dropped about 8 degrees Celsius between 2003 and 2012 at the start of Neptune's summer. Then, from 2018 to 2020, thermal images show that the planet's south pole brightened dramatically, indicating a spike of 11 degrees Celsius." End quote. With its giant orbit, Neptune spends 165 years orbiting the Sun. And the span of years from 2003 to 2020 is the equivalent of about 5 weeks on Earth. Let's call it June. This is one of those papers where I have to admit I read the paper and wondered at why our life lessons from Earth aren't applied to our expectations of other worlds. As first author of the related paper in Planetary Science Journal, Naomi Rao-Gurney points out, "We weren't expecting any seasonal changes to happen in this short time period because we're not even seeing a full season. It's all very strange and interesting." As Neptune continues to orbit, we'll get to watch the world settle into summer. Rao-Gurney comments, quote, "We need to keep observing over the next 20 years to see a full season and see if something else changes." End quote. And then we'll need 1,000 years or so to see how weird, or not, that particular summer was in comparison to a Neptunian lifetime of summers. In some rare good news about international space cooperation, NASA and the United Arab Emirates Space Agency have agreed to share science data between 2 Mars probes, NASA's MAVEN and UAE's HOPE. These 2 spacecraft are both studying the Martian atmosphere in complementary ways. MAVEN studies the upper atmosphere and ionosphere, and HOPE studies the upper and lower atmosphere. According to MAVEN PI Shannon Curry, quote, "Combined, we will have a much better understanding of the coupling between the two and the influence of the lower atmosphere on the escape to space of gas from the upper atmosphere." End quote.
One of the most important parts of a spacecraft is its cameras, which allow it to navigate and record science data. Since launch, the cameras on the Lucy spacecraft have been checked out several times, most recently back in February of this year. According to a NASA press release this week, all 4 cameras on the spacecraft are functioning properly, unlike the solar panels, one of which remains unlatched. The spacecraft is still generating 90% of planned power and is expected to successfully complete its mission in this state. The spacecraft has 3 different types of cameras: 2 close-range tracking cameras, a mid-range camera, and a long-range tracking camera. The pair of close-range cameras have the widest field of view and track the spacecraft's asteroid targets during close approach, ensuring that the rest of the instruments are pointed correctly. The mid-range camera, technically part of one of the instruments, L-Ralph, can be used for panoramas. L-Ralph is based on the Ralph instrument on New Horizons. The final camera, the long-range one, also shares most of its design and construction with the long-range reconnaissance imager on New Horizons, and is called L-LORRI, or Lucy LORRI. It will be used for high-resolution images of the targets with a narrow field of view. The February test demonstrated that all cameras were performing correctly and reaching the required sensitivity, and the camera pointing platform could point with the accuracy needed.
Earlier this week, we said that the MIRI instrument on JWST was in the process of cooling down to less than 7 Kelvin. That has now occurred, and the instrument passed its critical pinch point safely. As the instrument cooled, its ability to get cooler improves, except at a range around 15 Kelvin. The risk with this cryo-cooler operation was if there was more heat than initially modeled, the cryo-cooler would not have been able to reject all the heat and actually would have made the instrument warmer. The cooler is actually performing better than the engineers expected. This helps get down to the 6.4 Kelvin needed to suppress the thermal energy of the atoms in the detectors themselves, called dark current, which is bad because it imitates a real signal. Once the instrument was cooled down, engineers checked out the detectors and confirmed that they were healthy. And while we're going to have to wait a while to see what JWST sees in the sky for science, we have some things that you can go out this weekend, or in fact any night this week, and look up and see. Stay tuned.
This week in What's Up is the best time to see Mercury in the Northern Hemisphere, a meteor shower to look forward to next month, and more. First up is the Lyrids. On April 21st in the evening through the evening of the 22nd, the Lyrid meteor shower will be providing 10 to 15 meteors per hour. The meteors, which are orbiting roughly along with the Earth, appear to come from a fixed point in space, called radiant. If you traced the meteors back to the sky, most of them would converge back to this point. To find the radiant for the Lyrids, look to the northeast for the bright star Vega in the constellation Lyra. The radiant for the Lyrids can be found a little further east. The moon will be in its last quarter on April 23rd during the Lyrids, which should help with spotting meteors. Like the first quarter, this phase is also a good time to look at the moon in a telescope, with the additional promise of it being a new moon in a few short days' time, so you can look at faint fuzzies easier. Another thing to look for in Lyra is M57, the Ring Nebula, a planetary nebula. It can be easily located in the constellation between the two stars farthest from Vega. A planetary nebula is a white dwarf star which has stopped nuclear fusion and shed its outer layers into space. Early astronomers with telescopes confused these with nebulae, active star-forming regions. The name stuck. In most telescopes, it will be a gray smudge, but is nevertheless worth taking a look. With really good viewing conditions and a decent telescope, you may be able to see a hint of green. M57 is rather unique in that when you have perfect viewing conditions and a larger telescope, you may be able to faintly see the white dwarf star in the center of the nebula. Next is Mercury. Just after sunset on Saturday, April 24th, Mercury will be at its greatest heliocentric latitude north, meaning that it will be the highest elevation it will ever be in the evening this year. Look to the west-northwest and find the closest planet to the Sun. A few hours later, in that awkward time where it's too late to stay up and too early to wake up and then go back to sleep before you have to be up for real, aka 0530, in the morning Central Time, the crescent moon will be a few degrees away from both Mars and Saturn. These two planets will be joined in a line with Saturn and Venus further away. Finally, let's look ahead to next month. May brings a meteor shower, the Tau Herculids, which is what's left of comet 79P SW3, which disintegrated in 1995. SW3 was discovered in 1930 by two German astronomers while they were looking for asteroids. The disintegration made it much brighter than it was previously, so bright that it was visible with the unaided eye for a short period of time. Although the shower is called the Tau Herculids, the radiant this year will actually be in Bootes, near the globular cluster M3. The wandering of the radiant is caused by the gravitational pull of Jupiter, which has changed the orbit of the remnants of SW3. The shower will peak in a half-hour window on May 31st, starting at 0504 UTC, or 4 minutes after midnight Central Time, in the middle of the night from May 30th to 31st. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, and we hope you do, please consider joining our Patreon community at patreon.com/CosmoQuestX.